Ever since the expansion of the interstate system, with the explosion of bridges being built throughout the nation, we've been relying on them and we've used them to get us from East Coast to West Coast.
Infrastructure around the nation has been crumbling for quite some time, and municipalities, government entities all over are struggling to keep up with those needs.
So the BEAST is the first facility in the world where it combines physical loading as well as environmental loading to test full-scale bridges. Our load carriage would be passing on over 17,000 passes per day and creating 15 years of deterioration in 6 months. We would have the heating, we would have the rain come down on that deck, and we would also have the icing salts that we would see on any bridge across the country.
The high number of repetitions that the chassis makes on a daily basis requires an electrical solution to the problem. A mechanical solution would not withstand the repeated starts and stops. The Fuji electric VG drive was selected for this application simply because of the need for performance and robustness.
The carriage is loaded to simulate traffic conditions from 5,000 to 30,000 pounds. And we're doing that repeatedly, nonstop over a 6-month period of time.
That was a huge force demand on the system, so we had to go with a very large winch.
The winch is powered by a 400 horsepower motor, and the drum and motor are turned by a Fuji electric 400 horsepower variable frequency drive.
And so as this carriage is moving back and forth, it is a complex system. It's a system that relies upon the load carriage to be able to bring that load back and forth, and it relies on Fuji electric system drive that allows that 24-hour a day, 365 days a year operation so that our researchers can continue to look at that aging process.
The VG1 series drive is really the heart of the whole process. Anytime that we require precise movement and precise speed control, we rely on the Fuji electric VG for that.
The VG drive gave us the ability to put in acceleration curves. So rather than just hitting the accelerator and driving off as fast as you can, we were actually able to program in an acceleration curve. So you start off going slow, increase the amount of acceleration, but before we hit the beginning of the bridge where we're going to be going constant velocity, we also wanted to slow down that acceleration. And again, by transitioning through those changes slowly, we could program in using the VG drive the ability to speed up, get to the velocity we wanted, and then run it constantly. And that controller kept that in very tight tolerance throughout the whole profile. And by having the ability to use the VG's controller in order to do that, we were able to optimize the performance of the BEAST.
This type of project cannot compromise on quality. To do so would mean major delays in the experiments they are conducting.
We as researchers can't worry about a system failing.
We like to use suppliers that are going to be with us through thick and thin. We have products that we sell internationally, and our team really liked working with the Fuji Electric team in order to make sure that our nation's infrastructure can be economical for us to maintain over the coming years.
We're extremely excited to have a facility like this that allows us to study that, to come up with new materials, new innovations that will make sure that our bridges last longer.
This project is an example of Fuji Electric commitment to creating products that are socially responsible and can provide sustainable energy for the future.